Okay, so today we're going to start with our first kind of general rule. This will work for all triangles. It's really a big deal, I mean, trigonometrically speaking. But it's called the law of sines. Before we do this, though, it's worth looking at how we tend to label triangles. And this is, I've seen other times where they use Greek letters sometimes for the angles, but probably 95% of the time in here, we're going to label our triangles this way. The vertices we'll just call capital A, capital B, and capital C. Right? So angle A, angle B. And then the lengths were also going to be A, B, and C. We're going to use lowercase, and they're going to be named based on their opposites. So like angle A is opposite side A, angle B is opposite side B, and angle C is opposite side C. That's just sort of the convention for naming it. When we write our law of sines, which is right here, it's also on your note sheet, that's what that means. So it's what it's saying is, for any triangle, this is a really powerful rule. It's also a great way, no matter what kind of triangle you're ever working on, you can always check your answers if you have to solve it. Solving a triangle means you find all the unknowns, right? So by the end of the problem, you know all three sides and all three angles. But anytime you're doing that, a law of sines is a really easy way to check it, because it tells us that for any triangle, if you take the sine of angle A divided by the length of side A, or sine of B divided by the length of side B, or the sine of angle C divided by side C, that all these ratios will be the same. That's the law of sines. So there's powerful stuff there. Now, we tend to use this a couple different cases. Today we're going to focus on the cases where you're given two angles. Okay, so today we're going to look at, it says on your note sheet, if you are given angles in one side, then we will refer to this either as the angle side case or the angle side angle case. And hopefully you remember those congruency definitions from geometry. Right, this just means the side is between the two angles that you know. This means the side is not between the two angles that you know. So very straightforward. This is what we'll look at today. Law of sines also works with a side-side angle case, which is not a congruency statement that you can do in geometry. And we'll spend a lot more time with that next class we're together. Not tomorrow. I know, crazy schedule. These are the two cases we're going to look at now. So the first thing we know is, if you know two angles, you can always find the third one. That's not a big deal at all. Right? So let's go ahead then and look at our first example here. Okay, so for our first example here, we're given the following information in this triangle ABC. We're giving that angle B is 80 degrees, angle C is 34 degrees, and then we know this side length, we would call this side A, because it's opposite angle A, would have a length of 16. So the information we are given, that would be an angle side angle case. Right? We're given the angle side angle case. Now on this one, kind of unusual, it just asks us to solve for one side here, which we'll be able to do. Now before we do that, just to make the point to really drive this home, because it is a problem that can come up, this is a non-right triangle. So we can't use any of our SOHCAHTOA stuff. Right? There is no hypotenuse because there is no right angle. So you can't do any of that stuff. It's also not a right triangle. We cannot use the Pythagorean theorem. So that's a problem that'll happen sometimes. It's a great theorem, right? You want to use it all the time, but you can only use it with right triangles. This is not a right triangle. We can't use it. So what we can do, though, as we look at this, anytime we're using our law of sines, we want to get one of these ratios completely together. We want to have an angle side pair, is how I would refer to it. So if you know angle A, you want to know side A. That'll give you your pair. Then you'll choose one of the other ones and kind of fill in you get one unknown, solve for it. So in this case, we don't yet have an angle side pair, though. If you look, we know angle B, but we don't know side B. We know angle C, but we don't know side C. And we know side A, but we don't know angle A. Now the easiest thing to do there is we can just find angle A, right? Because we know that A will be 180 minus 80 minus 34. Is that 66 degrees? You're fine. Yeah. So that, I'm going to go ahead and put that on there, 66 degrees. So it didn't ask us for it, but we need that to help us solve. So now at this point, we do have an angle side pair. Right? We have that, we can write the sine of 66 degrees over 16. And then if we want to find side B, let's write equals the sine of 80 degrees over side B. So we set up this ratio. And generally when we're doing this, you're only going to take two of the pieces, set them equal to each other. Now at this point, we only have one unknown. We should be able to solve it. Be very careful. Make sure your calculator is in degree mode. Right? We're working with degrees primarily here. But go ahead and take a second and calculate that. Let's see what we get. Okay, so the first thing we'll want to do here is we'll want to cross multiply. Right? It's kind of what I would think of it. So we get B times the sine of 66 degrees equals 16 times the sine of 80 degrees. We'll go ahead and divide by the sine of 66. I would not type in anything until this last statement. Now at this point, I'm just going to type this in. One thing it might cause you problems if you forget to put the parenthesis after the 80 when you're doing this. So let's see, we get 16 sine of 80 and the parenthesis divided by the sine of 66. And that gives us, we go to two decimal places, which is fine. It gives us 17.25 would be our length for B. Everybody get that? That's the law of sines. That was a angle side angle case. Okay, so let's go ahead and look at our next example. Real quick though, before we move on to the second example, a check that you should always do when solving triangles. Always. It's super easy. You don't have to write anything down. You barely have to think. Okay, but this will always be true, is that the biggest angle should always be opposite the largest side. So in this case, of the three angles, we see that angle B is the greatest at 80 degrees. We see that B is the greatest of the sides that we know, which is what it should be. If we found what side C was, by setting up another ratio here, we would find that it would be smaller than 60. So always the biggest angle opposite the biggest side, the smallest angle opposite the smallest side. If that ever doesn't hold, then something went wrong. So that's a great, really easy check to do. Okay, so for our second example here, we have, we're given this triangle. Here we're given, this would be an angle side case, which to be honest, they really don't really work any different. There we go. So it's, but again, to do this, now there is an advantage on this one. You do have an angle side pair right away. Notice we have 50 and 12, right? That's important to note. So because of that, if I wanted to right away, I could even just set up and say the sine of 50 degrees over 12. And the other angle we know is the sine of 35 degrees over little b. So that's the first ratio I would set up. That's going to give us one of our sides. Now we are going to have to find the other angle, but that's not real difficult. So let's cross multiply. So b times the sine of 50 is 12 times the sine of 35. And then we'll divide by the sine of 50. Right, and then we'll just type that in our calculator. And when we do that, would we get 8.99?
Yes.
Okay, so that's one of the sides. Now if we're asked to solve it, which we are here, it doesn't really say, so we're going to find all the unknowns, correct? So the next unknown we probably want to find would be this other angle C, which is pretty straightforward, right? It's going to be 95 degrees.
Yes.
So C is 95 degrees. I'm going to circle the three pieces I'm supposed to find so that whoever grades it can find what I wanted to see. And then I'm going to go back and use this same ratio that we started with. You wouldn't have to, but 12 is a nicer number to work with than 8.99. So I would just stick to the one you were given. The sine of 50 degrees over 12 is the sine of 95 degrees over little c. Okay, so we'll cross multiply then. C times the sine of 50 degrees is equal to 12 times the sine of 95 degrees. So then from there, C is equal to 12 sine of 95 degrees over the sine of 50 degrees. So then C, I have 15.61. Now, the quick check I mentioned before is our biggest angle is 95, right? It's going to be one of two angle. That is our biggest side, that's good. Our smallest angle is 35, and 8.99 is our smallest side. So just again, just a really quick check that you don't have to do a lot of math to realize what's going on there. Questions? Example 2? Okay. Example 3, same, yes, question.
Are we always rounding to the 100th, or is it?
No, I don't know why I picked the 100th. You could go maybe at least one decimal place, or it just depends on the question. Yeah. Okay, so the third example here, what kind of triangle is this? Isosceles, which means two of the sides are the same. What else is the same? Yeah, the base angles are also congruent, right? So that's important. Once you realize that, you're pretty much there. So with this one, we realize that we're using 30 degrees here. There's 150 degrees left. So each of these base angles is 75 degrees, right? Which makes sense because we talked about these ratios have to be the same, right? So we know that if they have the same length sides, their opposite angles have to be the same also. So in order to finish this up, I guess we just found two of our unknowns, didn't we? Angle A is 75 degrees. Angle C is 75 degrees. And now we just need to find the length of either side A or side C, and then we'll know the length of the other one. So to set this up, we could say the sine of 30 degrees over 12 is equal to the sine of 75 degrees over little a, or you could choose little c. It really doesn't matter. They're the same length, the same ratio. So a times the sine of 30 degrees is 12 times the sine of 75 degrees. 12 sine 75 sine 30. And then we'll work that out, and we'll get, I get A is 23.18. Does it look right? Yeah. So what would C be? Yeah, 23.18 also. Last question to just ask us is what's the perimeter? The perimeter of a triangle, you just add up the three sides. So our perimeter is 23.18 plus 23.18 plus 12. Does it make sense this is bigger than 12? Right, see 12 is opposite 30. These are opposite 75. Bigger angle, bigger side. And we add these up and we get 58.36 would be our perimeter there. Is this working okay here?
Yeah.
Questions?
What case would this one be?
What case would this one be? I guess you could say, really not. I guess once we know this, I don't know. What case? To start with, we were given, it's really just a very special case because we're kind of given like two sides and an angle, but three sides and an angle. I guess it's side, side, side. You could think of it that way, or side angle. It just depends. It doesn't really follow because actually, until we do the base angles, we didn't have enough information to do it. So we had to use some prior knowledge. And once we knew the base angles, you could view it as an angle side, I guess. Would be the best way to answer that. Yes?
Does it honestly matter if we know what case it is? Because don't you solve them all the same way?
Yeah, as long as you know two angles, it really doesn't matter the cases. When we start to do the side-side angle, you might want to pay more attention to it.